Okay, guys, let's finish up these last two. So for number 11, it says two cars are driving towards each other on a straight, flat Kansas road. The Jeep Wrangler is traveling 82 kilometers per hour north. So the Jeep is traveling 82 kilometers per hour north. The Ford is traveling 48 kilometers per hour south. And it wants to know what the velocity of the Jeep is relative to the Ford. So since they're going towards each other, if you go back through your PowerPoints, you'll see this was like relative velocity example 2. You basically are just going to add these two together. So 82 plus 48 is 130 kilometers per hour. And if you're saying relative to the Ford, okay, so the Jeep looks like it is going 130 kilometers per hour to the north. Okay. All right, now on number 12, this one, and I'll just say for number 11 really quick, if they were going the same direction, what would you do there? You would actually end up subtracting. Okay, so if they're going in the same direction, then you end up kind of like just subtracting the numbers, and if they're going opposite directions, then you add. So maybe something like try to memorize that. Number 12, this is saying that if a small plane is flying directly west with an airspeed of 30 meters per second, so it's going like this, 30 meters per second, and the plane flies into a region where the wind is blowing at 10 meters per second at an angle 30 degrees to the south of west, so like this. So 10 meters per second, and this is 30 degrees right here. And it wants to know if the pilot does not change the heading of the plane, what will be the ground speed of the airplane. So that's like if somebody was over here on the ground looking at this, what would it look like their overall resultant speed is. So you're actually trying to find the resultant, which is that. Okay? So what does that mean? You're going to have to do your x and your y components again. So you've got x and y. So for this first leg, the one that was going straight west, does it have x component? Yep, it has all x component, right? Does it have y component? Nope, because it's going due west. And then it says that it flies into a region where the wind is blowing at 10 meters per second at 30 degrees. So we've got negative 10 cosine 30, and we have negative 10 sine 30, because if it's over here like this, then this is the third quadrant, so they are both negative. So you've got negative, let's see, so we've got negative 10 cosine 30, which equals negative 8.66. You got to add these two together here. So you've got negative 30 plus negative 8.66. So I've got negative 38.66. Got to do negative 10 sine 30, negative 5. So you got to do your Pythagorean, whoop, I don't know what happened there. Do your Pythagorean theorem. So you've got 38.66 squared plus 5 squared. Do the square root of that, and you get basically 38.98, or because of significant figures, see how these two numbers are 3 significant figures, so you would have to do 39.0 for that. And then on part B, so this was part A still, part B says what will be the new course relative to the ground of the airplane. So that's basically asking you to find the direction. So inverse tangent, your y over your x. you have 7.36 or 7 degrees. And what direction is it? Well, see this angle right here? That's what you're finding right there. So that's 7.37 degrees south of west. Okay. All right, that's it for chapter 3. If you have any questions, let me know.